Hello everyone, welcome to new class. Today's class is methods of analyzing circuits. So there are two methods of analyzing circuits, mesh analysis and nodal analysis. And the suitability of either mesh or nodal analysis is to a particular problem depends mainly on the number of voltage sources or current sources. If a network has a large number of voltage sources, it is useful to use mesh analysis, as this analysis requires that all the sources in a circuit to be voltage sources. Therefore, if there is any current source, then they are to be converted into equivalent voltage sources for the mesh analysis. And on the other hand, the network has more current sources, then nodal analysis is more useful. And mesh analysis is applicable only for planar circuits or planar networks, and for non-planar circuits mesh analysis is not applicable, and a circuit is said to be planar if it can be drawn on a plane surface without crossovers. So planar circuit means it can be drawn on a plane surface without crossovers, and a non-planar circuit cannot be drawn on a plane surface without a crossover. So, mesh analysis is applicable only for the planar networks. And a mesh. What do you mean by a mesh? Mesh means it is a loop which does not contain any other loops within it. So, mesh is defined as the loop which does not contain any other loops within it. And to apply mesh analysis, our first step is to check whether it is planar or non-planar networks. And the second is to select the mesh current. So first step is check whether it is a planar circuit or not. Second step is to select the mesh currents. And the final step is writing the Kirchhoff's voltage law equations. So, first step is check whether the circuit is planar or not. Then second one is to select the mesh currents. And the final step is writing the Kirchhoff's voltage law equations in terms of the unknowns, and solving them leads to the final solution. For example, consider the network shown. So here there is one voltage source given. So first of all, check whether this is planar circuit or not. So here there are no crossovers. So this is a planar circuit. Then next we have to select the mesh currents. So there are two loops. So this is first loop, this is second loop. So here let the current be I1 because the voltage source is here. So let us select current I1 in this direction. Then in this loop let the current be I2. So next step is write the KVL equations. So for the first loop, what will be the KVL equation? That is Vs is the source. So we can write Vs equal to I1 into R1. Then what will be the current through this branch R2? So through this branch, the current I1 is flowing in this direction and I2 in this direction. So the current here it will be I1 minus I2. So we can write I1 into R1 plus I1 minus I2 into R2. So this is the first equation. And for the second loop, after writing the KVL equation, we get R3 into I2 plus R4 into I2 plus, and through this is I1 minus I2 in this direction, and here I2 is flowing in this direction. So either we can write plus I2 minus I1 into R2 or minus I1 minus I2 into R2. So after writing the KVL equation for this second loop, we get 0 equal to, because here there is no voltage also in this loop. So 0 equal to I2 into R3 plus I2 into R4 plus, if we consider I2 is greater than I1, then it will be flowing in this direction. So we can write I2 minus I1 is flowing in this direction. So I2 minus I1 into R2. Or if we are considering I1 is greater, then it will be flowing in this direction. So in that case, we can write I2 R3 plus I2 R4 minus, because here this current is flowing in this way and this current is flowing in the opposite direction. So we have to put negative here. So minus I1 minus I2 into R2. So this is the KVL equations for this loop. Now we can solve these two equations and find the unknown values. So in this way we are doing the mesh analysis. So here we are discussing about a mesh analysis. Let us do a problem related to mesh analysis. Write the mesh equations in the circuit shown and find the currents. So this is the given network. So the first step is to check whether it is planar or not. So this is a planar circuit. Next we have to find the or select the currents. So there are two loops. So this is the first loop. Let the current be I1 and in the second loop it will be I2. So this is I1 in this direction and this is I2 in this direction, because there is a voltage source. So let that current be in the anti-clockwise direction. Now the next step is to write the KVL equations. So in the first loop we get 10 equal to 5I1 plus the current through 2 ohm is I1 plus I2. So 2 into I1 plus I2. Next, so this is 5I1 plus 2I1, that is 7I1 plus 2I2, 10. And next is, so this is first loop. In the second loop, we get 50 equal to 10I2 plus 2 into I1 plus I2, and that is equal to 2I1 plus 12I2. So this is the first equation and this is the second equation. So on solving these two equations, we get the values of I1 and I2. So using a scientific calculator, we can easily solve these two equations. So in the calculator, first of all, the mode is selected in equation, that is 1. Then unknowns. So here there are two unknowns. So press 2. A1. A1 is the first one's coefficient. So here coefficient is 7. So 7. Then B1 is 2. That is 2. Then equal to. Next is C1. C1 is the constant, that is 10. Equal to. Next is A2. A2 means the second equation is the first coefficient, that is 2. So 2 equal to. Then B2 is again 12. Then C2 is 50. So x means here I1. So I1 is 0.25. Then I2, that is y. I2 is 4.125. So we get I1 equal to 0.25 ampere and I2 equal to 4.125 ampere. So in this way we are doing the mesh analysis. Let us do another problem. Determine the mesh current I1 in the circuit shown. So this is the given circuit. So there are no crossovers. So this is a planar circuit. Now we have to select the currents. So there are 3 loops. And another way to find the number of equations in mesh analysis is, that is the number of equations or mesh equations equal to number of branches minus number of nodes minus 1, or we can write b minus n plus 1. That is number of branches minus number of nodes plus 1 is equal to the number of mesh equations. So these are the branches, or there are 3 loops. So there will be 3 equations. First of all, mark the nodes. So there are 4 nodes. A, B, C and D are the nodes. So there are 4 nodes. Then number of branches. So between the nodes we have to select the branches. So this is one branch. Then 1, 2, 3, then 4, 5, 6. So there are 6 branches, then plus 1, that is 2 plus 1, that is 3. So there will be 3 mesh equations in this network. So in this way we are finding the number of mesh equations. Now we can select the currents. So let the current in this loop be I1, then I2 and I3. So I1, I2 and I3 are the 3 currents in the 3 loops. So I1 is in the clockwise direction, I2 and I3 are in the anti-clockwise direction. So now we have to write the KVL equations. So consider the first loop. Then we get 10 I1 plus, then through the 5 ohm resistor the current flowing is I1 plus I2. So through the 5 ohm resistor the current is I1 plus I2. So we can write 5 into I1 plus I2, that is 5 into I1 plus I2, Then through the 3 ohm resistor, the current flowing is I1 plus I3. So we can write it plus 3 into I1 plus I3. Then here there is a voltage also, so we can equate it to 50. Now rearrange these equations, then we get 10 plus 5 plus 3, that is 18 I1 plus 5 I2 plus 3 I3 is equal to 50. So this is the first equation. Then consider the second loop. Then we get 2 into I2, then plus 5 into I1 plus I2, then through the 1 ohm resistor, I2 is flowing in this direction and I3 in the opposite direction. So we can write plus 1 into I2 minus I3. So I2 minus I3, and that is equal to 10. So here there is a voltage source. So this is I2 minus I3 through the 1 ohm resistor. Now we can rearrange this one. That is 5 I1, then plus here 2 I2, 5 I2, 1 I2. That is 8 I2, then minus I3 is equal to 10. So this is the second equation. Now consider the third loop. So in the third loop, through the 1 ohm resistor, current flowing is I3 minus I2. So we can take that one as positive. Then 1 into I3 minus I2. So if we take I2 minus I3, then this one will be minus. So here 1 into I3 minus I2, then plus through the 3 ohm resistor, 3 into I1 plus I3 is equal to the voltage source is 5. Now rearrange this one. Then we get 3 into I1. Then here this is minus I2. So minus I2. Then here 1 I3, 3 I3, that is 4 I3 is equal to 5. So this is the third equation. And here the question is find the current I1. So to find I1, we need not solve all the unknowns. So only we can find I1 using the Cramer's rule. So for the Cramer's rule, we have to find the determinants. So in the Cramer's rule, we are writing the coefficients of I1, I2, I3 as a matrix, and the constant terms, that is the voltage source here, the constant terms in the another column matrix. So these equations we can write in matrix form like that, that is 18, 5, 3, 5, 8, minus 1, 3, minus 1, 4 into the unknown coefficients are I1, I2, I3, that is equal to 50, 10 and 5. Now we can find I1. So I1 is equal to determinant of, rearrange the first column with the constant term. That is, to find I1, the first column is replaced with the constant term in the right side, that is 50, 10, 5, and the remaining two columns are written as the same. 5, 8 minus 1, then 3 minus 1, 4. Then divided by the determinant of 18, 5, 3, then 5, 8 minus 1, 3 minus 1, 4. So, in this way, we are finding I1. Also, to find I2, replace the second column with the constant column matrix. Then, for the I3, here replace the third column with the constant terms and denominator is same as that of the original matrix. That is determinant of the given values. That is 18, 5, 3, 5, 8 minus 1, 3 minus 1, 4. Now we can find the determinant. We can find the determinant using scientific calculator. So in scientific calculator, first of all select matrix form. That is matrix mode, then 2. Now enter the data shift matrix dimension. So let the matrix be A. Then order of the matrix here is 3 by 3. Then enter the elements. The first element here is 50, then 5, then 3, 10, 8, minus 1, then 5, minus 1, then 4. Now press this one. Now to find the determinant, shift matrix determinant of again shift matrix 3, the matrix A, then equal to, it is 1175. Now to find the denominator value, again shift matrix dimension 1. It is already given 3 by 3 matrix. So here we have to change the first column matrix values. All other values are same. So here we can change the first column values. That is A11 is here 18, then 5, 3. Next here 10, that we have to change 5. Then A22 is 8, A23 is minus 1, that we have to change 3. Then minus 1, 4. Next press this one. Now we can find the determinant. That is determinant of shift matrix 3A. That is 356. So here we get I1 as 3.3 ampere. Similarly, we can find I2. That is I2 is equal to, change the second column elements, that is 18, 5, 3, then 50, 10, 5, 3 minus 1, 4. So determinant of this one divided by determinant of this one, that is 356. Then I3. I3 is equal to, change the third column elements, that is 18, 5, 3, then 5, 8 minus 1, then 50, 10 and 5 divided by 356. So for I2 we get minus 355 divided by 356 and minus 0.997 ampere, and for I3 we get minus 525 divided by 356 and that is equal to minus 1.47 ampere. So in this way we are doing the mesh analysis. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.